This section on the mole, molar mass, and stoichiometry is based on material in Chapter 7 and Chapter 9. The unit of the mole is based on Avogadro's number, or 6.02 times 10 to the 23rd, which is the number of atoms in exactly 12 grams of the isotope carbon-12. There are 3 units that the mole can be converted to or from. Dividing a number of particles by Avogadro's number gets you to moles, or multiplying the number of moles by Avogadro's number gets you back to the number of particles. Dividing a mass in grams by the molar mass gets you moles, or multiplying moles by molar mass gives you the mass in grams of that substance. Or dividing the volume in liters of a gas at STP, standard temperature and pressure, by 22.4 gets you moles, or multiplying the number of moles by 22.4 gives you the volume of the gas in liters at standard temperature and pressure. Taking a look at number 43, stoichiometry problems here are all about combining various mole conversions and ratios of substances from a balanced reaction to calculate the amount of a product that's formed or the amount of a reactant that's required. So here in number 43, we're given 11 grams of hydrogen gas, and we're trying to find out what mass of water is going to be produced. So once we're given 11 grams of hydrogen, we're going to convert to moles by dividing by its molar mass to get 5.5 moles of hydrogen. Next, we look at the wanted to given ratio. It's a 2-to-2 ratio between the water and the hydrogen gas. So there are also going to be 5.5 moles of water produced. And finally, we convert to the desired unit. And in this case, we want grams of water. So we're going to multiply by the molar mass of water to get a final mass of 99 grams of water that are going to be produced. Number 51 is a really good example of what a performance task type problem that you might be asked to do on the final would be. It describes a reaction and gives data for the amounts of various substances. Here we're required to find out the mass of precipitate formed and do various mole conversions in stoichiometry with that amount. So looking at A, we're trying to find out how much precipitate is formed, which means we have to subtract the mass of the filter paper with the precipitate in it after it's been dried, and the mass of just the filter paper by itself to get the mass of the precipitate. In C, since we know that the precipitate, and we know it's a precipitate here because it says it's a solid in the balanced equation, the lead 2 iodide has a molar mass of 461. So if we divide the mass by its molar mass, we find out how many moles of lead 2 iodide we get. In D, we can multiply that number of moles by Avogadro's number to find out how many molecules. And in part E, since it's a 2-to-1 ratio from the balanced equation between the potassium iodide and the lead 2 iodide, we know that we're going to need double the amount of moles of lead iodide. So a 2-to-1 ratio times that number of moles gets us 0.024 moles of Ki, and again we can convert to grams by multiplying by the molar mass of Ki to find out how many grams we would need. In F, it's just another stoichiometry problem. Whenever you see theoretical yield, it's just another way of asking you the amount that should be formed according to your calculations. And then I'll scroll down a little bit here so you can take a look at the solution to number 52.